Hi everyone, welcome back. This is me attempting longest common prefix, which is rated as an easy question, but I would say it's slightly harder than a typical easy question, so let's get straight to it. So the question expects us to write a function that will find the longest common prefix amongst an array of string. So prefix refers to the first few letters of from the front, the letters from the front. So I believe this is what made them decide this will be easy because by setting the limitation that we're looking only from the front, we can just compare across the front of the different words. And the second there's a difference or a discrepancy, we can just early terminate and we don't need to pass through the entire string. So that is a benefit, and I believe that's how the approach to look at this as well. Always think of where we can optimize, like early terminate or repeat some processes, etc. So that is the strategy that I'm looking forward to as well. But let's go through the example. So for this case, FL is the only thing that's common across the front. So FL, flight, flow, and flower. And as for the next example, there's nothing in common in the front. So the second that there's a difference, we just can early terminate and say nothing is common. So we need a way to check across all of them and only check the first letter by first letter. So what do I mean by that? We need a sort of checker that looks like this. Flow, flower, and flight. We need something like a counter that will keep count of the index that we are traversing through first. So let's say the counter starts at, so the counter will start at 0, and we're checking the 0th index item, F, F, F. So counter can increase by 1. So next, go to the next item. It's L and L and L. So it passes this, we can go to the next one. So we increase count by 2. And we see O and I, which is different. So then we have to terminate and return whatever was common before this, and that will be the answer. So the first two indexes, which is what they returned as FL. So yeah, this is the logic behind how we will be coding it, but maybe some of you prefer to see it as a code. So I'll just erase this part of things and I will get straight to it. So first thing, as mentioned, I'm going to set a counter just to keep count of things. And I'm also going to have a base word, like an initial word, and the initial word to compare against. So in this case, the initial word will be flower, but it will be anything as our program states. So STRS contains the array of different words. So we will just be storing the first word into init. And what I'm going to do is I'm going to run a for loop that's of the size of init. And whether we choose the right init doesn't matter because it has to be common. We'll be comparing across all the different words eventually. So an arbitrary flower to set the initial state is good enough. So this is 1, 2, 3, 4, 5, 6. So it'll be for I in range 6, we'll be checking the 6 indexes in the across all the words in the array. Does it matter if it's too long? No, because if it's too long, it'll just early terminate when we see the terminating condition somewhere. Does it matter if it's too short? No, because if it's too short, it is likely to be the most it is likely to, yes, we will always find the answer across all the words, so it doesn't matter which word we choose. So yeah, that's the idea that maybe I'm explaining too much. Anyways, so for I in range length 6 in this case, I'm going to I'm going to put a first word. The first word is init I. So that would be the word that we compare against across all the words in the list. So word in STRS. If word I is equal to first, we can continue. Else, we terminate. So if the word and the first element is the same, we continue with it. But if it's not the same, we have to terminate and return whatever has been seen so far. So that would be we just return. We can return with the base word in it, and it will be count, but count is not updating at the moment. Count will basically update when we see through all the words. Like we have passed through all the words. We see flower, flow, and flight. The ith index is the same. We continue. If we are able to pass through the for loop over here at this index, we increase the count by 1. So count will increase by 1. And if it's different, we just return whatever we have seen so far. Like for the base word, it should be the same, because for the it only progresses to the next stage if all of them are the same beforehand, like in the previous comparisons. If for whatever reason, like we are seeing the full thing, like we have passed through the full length of init, like maybe init is the smallest item in the word array, and it's just so happens to that it doesn't early terminate anywhere else. We just return in the finale init count, and this should be sufficient to make sure that we only get the longest common prefix, because we compare against all the words, and we compare just index by index. We don't compare wholesale and find out the answer. So this should work, but I think let's go step by step. I might have missed out something, and it's a learning process. So it runs on the run. Let's submit, and I think there might be an issue. Yeah, okay. So word, we're comparing the word, we're comparing each word. Like for in this case, what they're basically saying is string is out of range. So I is basically too bigger than the word itself. Like whatever word that I'm testing, like whatever index that I'm testing, if it exists, is too big. Like for instance, in the flower case, flower versus flow, maybe F and F is there, L and L is there, O and O is there, W is there. But the second it goes to the next element, it'll go to count, will go to E. Like I is the next, I will go to 0, 1, 2, 3, 4. I will become 4. And when it goes to what is the fourth index in flow, there's nothing there. Hence, it'll return an error. So to prevent that, we need to do an early checking as well. You basically check if the word, you basically check if I is smaller than the word itself. And this should be sufficient. Like if this itself doesn't work, there's no point comparing if the letter is the same as the first letter. If the letter is the same as this. So yeah, I think this should do the trick. So yeah, okay. We have beat 61% and beats 34% in memory, and yeah. So this is an efficient solution, because even though we compare across all the words, we don't compare all the letters in all the words. We do that step by step, and we do in a way that early terminates as well. So it will be effectively, we are looking at all the elements to compare only once. And for that reason, this will be a O(n) time complexity, and we are not initiating new memory space for this. So it's constant memory space as well. So yeah, let me know what you guys think, and if there's any room for improvement anywhere, also let me know. And I hope you guys enjoyed the video, and I'll see you guys in the next one. Thank you.